All right, hello. Uh, Good afternoon, or whenever you're watching this. My name is William Messick, and I'm going to be talking about designing a sorting algorithm using CUDA, leveraging the secret power of the GPU. All right. So, what is CUDA? CUDA stands for Compute Unified Device Architecture, and so this is a toolkit that you add to a language that enables you to um, use a GPU. So parallel computing, it's a parallel computing platform and programming model built by NVIDIA for general computing on GPUs. It's able to dramatically speed up computing applications by harnessing the power of GPUs. All right, so I think it's important for this discussion to briefly go over the differences. Um, we have a central processing unit versus a graphical processing unit. One has several cores. GPUs tend to have thousands of cores. Um, CPU has low latency. However, GPU has very high throughput. CPU is good for serial processing, doing one thing right after another. GPU is amazing at parallel processing, doing stuff at the same time. CPU can do a handful of operations at one time. However, GPU can do thousands. All right, so why are we going to use CUDA for sorting? It's because of the high degree of parallelism. Um, so we're going to have all of these thousands of cores working together. We also have increased throughput because we have all of these different pipelines going on at the same time. We're going to have a lot of output and faster processing time. And we're not going to be using bowl sort. I just wanted to add a little video right there. All right, so I want to find a sorting algorithm, one that's good for um, parallelized or parallelization, uh, especially for large data sets, and I wanted to try something new. So I settled on this idea, this algorithm called the Bytonic sort. Um, and you'll see it's kind of a strange algorithm. It sorts stuff, half the stuff in ascending order, while the other half is descending order. All right, so talking about the project scope and goals. So for this project, I'm aiming to implement the sorting algorithm, the Bytonic sort, using CUDA. Um, I want to utilize my GPU instead of my CPU. So I'm going to design two different versions of this algorithm, one for my CPU and one for my GPU. The goal is to achieve a more efficient sorting algorithm through the GPU and demonstrate improvement over the CPU. All right, so this is standard C code on the left and C with CUDA extensions. This is what I meant by CUDA being a toolkit. It is an addition to a language that enables you to use different threads or kernels for the GPU. So this is an example of the same algorithm, um, same code, but designed using GPUs instead. And as you can see, there's a few keywords. We have global, that block IDX, block dimension, and so on, etc. All right, so CUDA kind of exists in between a lot of different platforms and layers, so it can get a little bit confusing. What we still see down here, we have the CUDA toolkit. At the bottom, we have our OS platform, so I'm going to be working with Windows. Um, Additionally, we have our CUDA X libraries. I'm going to be working in C++, but as you can see, it's available to be used in other languages. And then these are some apps and frameworks. Some of them are very commonly used with CUDA, for example, TensorFlow or PyTorch. And you see, it's very far removed from a use case. All right, so the first thing I want to do is check that my machine is compatible with CUDA. So um, I went ahead and checked here. I do have an NVIDIA GeForce RTX, so I'm going to be able to use CUDA. And down here is the list. If you go on NVIDIA.com, um, um, GPUs that can run CUDA. And then I went ahead and installed CUDA for my Windows machine. All right, so unfortunately, I ran into a lot of challenges. Originally, my project was to have a dual computer setup and to run some rendering through both of them at the same time. However, I had multiple power outages while doing this. I think part of it's just it's the summer. A lot of people are using air conditioning units. Um, but I spent a significant amount of time fixing up that old computer. At one point, I think it blew my power outlet because the power in my apartment was out. Uh, and lastly, I had challenges setting up my toolkit. I got rid of CUDA a few times. I reinstalled it. I went through a lot of forum posts trying to figure out what's up with my CUDA code. Um, okay, so let's go ahead and talk about performance metrics. Unfortunately, because I wasn't able to run the CUDA code, um, I'm not going to have anything to compare it, but I'll go ahead and show you my code for the CPU version without CUDA. Go ahead and just bring that over here. All right. Okay, so this is the CPU version here. It works a little bit like merge sort in that it keeps splitting into smaller and smaller buckets, and then sorting those buckets. So we're gonna start with compare and swap. So it's the helper function that swaps the elements based on a sorting direction, which is going to be 0 or 1. Based on 0 is descending, or 1 is ascending. Then we're going to go ahead and do the merge here. Right here, the sort, this divides the arrays into 2 halves, and then using recursion, sorts each half the opposite ascending order, or sorting order, and then merges them. All right, sort. Um, this is going to get the sorting process done. Let's see. Well, I'll get back to that. And then here, so Pythonic sort actually works with power of 2, so we need to use a little padding function to make sure if the user doesn't give us one, that we can fix that. We have a random number generator. I put these numbers at a small, they're random numbers just to make it a little easier. Um, we're sorting, this is what we're calling the sort function, and yeah. And so the CUDA version is pretty similar. It's just offloading some of the sorting computations to the GPU. So this is checking the error right here. CUDA kernel to perform Pythonic merge. So this is enabling the GPU, of course, to run the sort instead. It's pretty similar. Like I said, though, I just couldn't get it to run. It wasn't my system just wasn't recognizing it. But yeah, I guess here, go ahead and run it. So we have CPU Python sort. So this is the non-CUDA version, and I'll just put a small array really quick, size 50. It takes 20 seconds. Let's run that again. We'll do size 10,000, 10.64 seconds. So it's pretty quick. We're gonna try that one more time. We're gonna do 100,000. So that's less than a second, and then the last one we have 1 million. And there you go. happened in less than 1 second. So I'd say it's a pretty fast algorithm. All right, and that concludes my presentation. And here is where I would have some questions. Uh, I have an audience today, and here's some of my references. All right, thank you.